Welcome, my curious learners, to the world of artificial intelligence. In today's video, we embark on an exciting journey to demystify the fundamentals of artificial neural networks, ANNs, and their pivotal role in AI. So, let's dive in and explore the marvels of this extraordinary field. At the heart of AI, we find artificial neural networks, ANNs, which draw inspiration from the workings of the human brain. Artificial neural networks aim to replicate the brain's ability to process and interpret information in order to solve complex problems. Just like the brain, ANNs consist of interconnected units called neurons working together to perform computations. The structure of ANNs is composed of layers: an input layer, hidden layers, and an output layer. The input layer receives the data to be processed, which is then passed through the hidden layers, where the magic happens. The hidden layers perform computations using weighted connections, which capture the complexity of the problem at hand. Finally, the output layer provides the solution or prediction generated by the ANN. Now, let's explore the building blocks that make up ANNs. Neurons, the fundamental units of artificial neural networks, receive input signals and produce an output signal using an activation function. These activation functions introduce non-linear behavior, enabling ANNs to model complex relationships in the data. The connections between neurons, represented by weights, determine the strength and influence of each connection. The training process is where ANNs truly shine. Through training, ANNs learn from example data in a way that mimics human learning. The training phase involves presenting the ANN with a set of input-output pairs and adjusting the weights of the connections to minimize the difference between the predicted outputs and the true outputs. This optimization process, often done using techniques like gradient descent, allows the ANN to gradually improve its performance over time. As ANNs train, they optimize their ability to generalize from the training data to unseen examples. This ability to generalize is what makes ANNs powerful problem solvers. ANNs can learn patterns, classify objects, make predictions, and even generate creative outputs like music or art. The applications of ANNs span a vast array of fields. In the realm of computer vision, ANNs are employed for tasks such as image classification, object detection, and facial recognition. In natural language processing, ANNs enable machine translation, sentiment analysis, and text generation. ANNs are also extensively used in recommendation systems, financial forecasting, robotics, and many other domains where intelligent decision-making is required. In conclusion, artificial neural networks are the building blocks of AI, allowing us to model complex problems and make intelligent decisions. ANNs replicate the brain's computational power, providing us with the ability to solve diverse real-world challenges. The potential of ANNs is vast and continues to expand as we push the boundaries of AI. Thank you for joining us on this illuminating journey. We hope you now have a solid understanding of artificial neural networks. Don't forget to like, share, and subscribe to our channel for more simplified explanations of AI concepts. If you have any questions or suggestions for future topics, feel free to leave a comment below. Keep exploring the captivating world of AI, stay curious, and happy learning.